Hello and welcome to my channel, Boo Snakes and More. Today we're going to be talking about atmospheric science. So please like this video and subscribe to the channel. And for more videos like this, also watch my other house channel, A&A Snakes and Stuff. My youngest son's channel, Henny's Toys and Games, or my oldest son's channel, Little Chris 10. Now let's dive into the video. Delivering major new insights in the fight against climate change. The Tempo mission will be a capstone to Kelly Chance's career, which has focused on advancing the power of spectroscopy to study Earth's atmosphere. From the heyday of giant sensor-toting balloons several decades ago to today's overhead fleet of modern spectacular Earth-observing satellites, atmospheric science has come a long way instrumentally. Kelly Chance, 75, a senior psychiatrist at the Center for Astrophysics, or physicist at the Center for Astrophysics, Harvard and Smithsonian, has not only had a front row seat to this progress, he has also been one of its prime movers with the upcoming launch of TEMPO, telescopic emissions monitoring of pollution, early next year. Chance and his colleagues will once again define the state of the art in instrumentation for atmospheric science. A NASA-funded mission, TEMPO will be the first spaceborne instrument to measure air pollution across North America on an hourly basis and with resolution down to a mere 4 square miles, a tremendous advance over today's roughly 155 square mile capability. This unpredicted temporal and spectral coverage is expected to revolutionize air quality forecasting, as well as deliver major new insights into numerous fields including climate science and agriculture. With TEMPO, we don't measure the whole Earth like other instruments do. We instead measure a little part of the Earth, and we're able to do that all day long, says Chance, who serves as the principal investigator for TEMPO. We'll also measure a much smaller footprint on the ground than ever before, a little bigger than the National Mall in Washington, D.C. For Chance, TEMPO represents a culmination of a transformative career. Chance was born in his family's small town of Shamrock in the Texas Panhandle, then moved frequently throughout his early life, from Arizona and California to Virginia, Alabama, and even Tokyo. He eventually moved to Massachusetts to attend Harvard University in the 1970s and pursued a graduate degree in physics and a PhD in chemical physics. Chance's abiding interest connecting these studies with spectroscopy, the science of how matter absorbs and emits electromagnetic radiation, or light. Breaking this light apart into a spectrum reveals characteristics of the matter involved. Due to total absorption and emission, signatures implanted by the matter's constellant molecules. Spectroscopy was a particularly strong interest of mine, says Chance. I like seeing how molecules work. Kelly Chance, an astrophysicist at the Center for Astrophysics, Harvard and Smithsonian, is the PI of the TEMPO project. For his postdoc, Chance had an opportunity to go right up the hill in Cambridge to the Smithsonian Astrophysical Observatory (SAO) and pursue instrument development for astrophysical science. In those days, it was scientific ballooning, where we would send balloons the size of Fenway Park up into the stratosphere. Chance recalls he personally helped devise balloon-borne instruments that measured stratospheric chemistry starting about 6 miles above Earth. As the work continued, though, Chance realized, thanks to his background in spectroscopy, that faulty data could be wrung out of the air and at lower altitudes down into the troposphere, the bottommost layer of the atmosphere where nearly all weather takes place, and which accordingly has the greatest impact on human activity and well-being. We had brilliant people who knew how to build instruments and do the engineering, but we did not have professional spectroscopes. Such Chance, it turned out I knew how to measure things that other people didn't. With colleagues in Germany, Chance proceeded to usher in a new era of atmosphere probing instrumentation. In 1985, he performed an ambitious advancing of capabilities in space-based spectroscopy using ultraviolet and visible light. Observations of this kind could gauge the chemistry of the troposphere as never before. The two initial instruments that eventually flew included NOME and Shomatry on European Space Agency satellites in 1995 and 2002, respectively. These instruments captured regulated air pollutants with harmful health effects such as ozone, which at ground level forms smog, as well as nitrogen dioxide and sulfur dioxide. Getting to newly measure this stuff through spectroscopy. It was like shooting fish in a barrel, Chance says. TEMPO represents the next generation of the scientific endeavor, promising a deeper understanding of these critical pollutants, origins, and their impacts on atmospheric chemistry. Proposed in 2012 by Chance and colleagues, TEMPO is the first mission in NASA's low-cost Earth Ventral Instrument EV-1 program. Boulder, Colorado-based Bell Aerospace recently completed building the TEMPO instrument, about a cubic yard in size, or about washing machine size. TEMPO looks like a framework of metal tubes with disc-shaped turntable on top, says Chance. That rotating section toggles through open, closed, and collaboration positions, collecting light that pings upon a spectrometer. The whole instrument is presently undergoing integration and testing alongside other payloads aboard Starlink E-40E, a commercial communication satellite slated to launch in early 2023 aboard a SpaceX rocket.
Well, bye. I'm going back to my area.
Once aloft, the satellite will resume a gastrooriented orbit, meaning the spacecraft will orbit the planet over a period equal to Earth's.
Space. Space is so cool.
Rotation. The orbit ports some 22,000 miles up, will park TEMPO over the North American continent and grant a view of Mexico from Mexico City up to the Canadian oil sands. Given this grand vista, the TEMPO collaboration includes science teams based in those countries, plus Cuba, we have a huge number of people who have pursued proposed experiments and who are ready to get their hands on Tempo data, says Chance. Tempo is satellite for all of us. With its graduative measurements in both time and space, Tempo will offer many practical applications alongside fundamental science. One example is commercial weather forecasting, which involves alerting the public about poor air quality brought on by high levels of particulate matter, violent organic compounds, nitrogen dioxide, and other unhealthy chemicals. Based on key new data from Tempo, we hope you'll be able to take out your smartphone and look at an app and ask, "Can I run this morning?" says Chance. Thank you for watching this video and peace out to the next one.